Hello there, Wildcats. Welcome to your Algebra 1 class. And in the previous video on our previous topic, we discussed about factoring using GCF. Now, in this video, you will be learning about factoring x squared plus bx plus c, which is basically this is your quadratic equation. So our objectives for this lesson is student will be able to first is factor a trinomial in the form x squared plus bx plus c by finding two binomial factors whose product is equal to the trinomial. Second is identify patterns in the signs of the coefficient of the terms of the trinomial expression and use those patterns to determine the sign of the second term in the binomial factor. And lastly, we have to factor trinomials in the context of solving real-world problem. Essential understanding: when a trinomial is in the form x squared plus bx plus c, the factors are found in identifying the pair of integer factor of c that have a sum of b, and then using the factors to write binomial that have a product equal to the trinomial. So we are going to review the following vocabulary: binomial factor, distributive property, factor, or GCF, greatest common factor, and monomial and polynomial. So these are the vocabulary that we will encounter in this lesson. All right, let's jump into the conceptual understanding of this topic, factoring a x squared plus bx plus c, which is a example of a trinomial and it's quadratic. So we'll understand. So the concept here is we have to understand factoring a trinomial. So first is we have, how does factoring a trinomial relate to multiplying binomials? Okay, so that's what I have said. We'll be going back to distributive property. So we have to consider the binomial product of x plus 2 times x plus 3, which is these two are binomial because there are two terms there, and the trinomial x squared plus 5x plus 6. So I have to rewrite that so you can see it there. I'm sorry, I'll have to go back to change color here so you can see. We have this binomial here, x plus 2, okay, times x plus 3. And if I'm going to relate that to, or I have to use distributive property, this will give me x squared plus 3x. I have to erase that. X squared plus 3x, not 2x. Okay, so x squared plus 3x plus, so I'll go to the 2x times 3 will be, 2 times 3 will give us 6. Okay, and then I have x squared plus 5x plus 6. If you will notice here, okay, when I did distribute, when I multiply these two binomial, the answer is x squared plus 5x plus 6, which is the given trinomial here, okay, which is the given trinomial. As we can see, the product of the second term of the binomials is equal to the last term of the trinomial. So the product, I'll repeat that, the product of the last terms of the binomial is equal to the last term in the trinomial, which is the 6. Okay. Also, if you will notice here that the sum, okay, the sum of the second term of the binomial is equal to the coefficient of the second term of the trinomial. So the two here plus 3, it's the 5. So 2 plus 3 is 5, and 2 times 3 is equal to 6. Therefore, we can now say that when factoring a trinomial, you work backward to try to find the related binomial factor whose product equals the trinomial. Therefore, by just looking into that, okay, with that pattern, I'll just use blue color here. With that pattern, we can see that you can factor a trinomial in the form x squared plus bx plus c. That would give us as a x plus p times x plus q. Okay, if I multiply my p times q, would give me the c. So p times q will give me the c. And if I add them, p plus q will also give me your c. Okay, so that's the pattern as what I'm saying here. So when I multiply my p and q there, which my p is 2 and my q is 3, that would give me the c on the trinomial. And then if I add my p and q in the two binomial there, and then that will give me the c on the trinomial. So meaning you will be working no, not c. P plus q is b. I'm sorry about that. P plus q will be equivalent to the it's equivalent to the middle term of the trinomial. This is b. Sorry about that. So let's apply that. We are going to factor x squared plus 5x plus 6. Okay. You have to think about the different ways you could organize the factor and their sum. So what organizational tool would be useful? You can use a table. Okay. You can use what do you call this one? The family tree of numbers. So first is we will identify two numbers that if you multiply will give you 6, but if you add will give you 5. So I could use a table here. So what is the factor of 6? And then factor of 6, meaning when you multiply them together will give you 6. And the sum of factors. So what is the sum of the factor you have chosen? Sum of the factors. Okay. I can give 1 and 6. 1 and 6, if I add that, it's 7, which is, it's not 5. 2 and 3. 2 and 3, if I add it, it's 6. So we'll be using this one. Sorry about that. So we'll be using the second. So we'll be using 2 and 3 as the factor. So you can now write there as the factor so the factor of x squared plus 5x plus 6 is equal to, okay, x plus 2, okay, times, maybe I can rewrite this one in the lower part because I don't have enough space there. So let's say that x squared plus 5x plus 6 is equal to x plus 2 times x plus 3. So that if you will add 2 plus 3, it's the middle term in the trinomial, which is 5. And then 2 times 3, that is equivalent to 6. There's a lot of ways, okay? There's a lot of ways to factor a given a trinomial in the form x squared plus bx plus c. This is just only one way, guys, okay? Let's take another example here. So factor x squared and then x squared plus bx plus c when your b is less than 0 but your c is greater than 0. We have to identify the factor pair of the 18 that has a sum of -11. So again, I'm going to use a table here. Factor of 18, and then sum of sum of the factor. I'll just be careful on writing there. Sum of factors. So think of two number. So -1 times 18, -1 and -18. That will give me -19, which is not. How about -2 and -9? Oh, there you go. -2 and -9 will give me -11 when I add that. So because b is negative and c is positive, inspect only negative factor. Okay, so again, I'll repeat that. On a given trinomial, if you will see that the value of your b is negative and your c is positive, make sure that both factor must be negative. Okay, so we'll be using this one. Therefore, the factored form of x squared minus 11x plus 18 is equivalent to x minus 2, because it's negative, times x minus 9. So if you will do the distributive property, you will come up with an answer of x squared minus 11x plus 18, because -2 plus -9 will give you -11, and then -2 times a negative number 9 will give you positive 18. Even though there are more factor pairs of 18, there is no need to continue once you have find the correct answer. So there's a lot of factors there, but there's only one factor that has, when you add this two, will give you the value of b in your equation, and then if you multiply, will give you the c. Okay. Next is what if you have c is less than, there you go. What if c is when c is less than 0? Okay, so in here we'll just you will see here, what is the factor of x squared plus 5x minus 6? The same. So we'll do what are the factors of factor of -6, that's less than 0, and then sum of factors. So what is the sum of that factors that you so make sure that the sum of factors will be the middle term, which is 5. So you're looking at the sum would be 5, and then when you do the factor, will give you -6. So 1 and -6, 1 and -6, that will give me -5. So exchange that, -1 and +6. 6 minus 1 is +5. So we'll be using this one. I just want to emphasize in the on the common errors that we are committing here. You may think that the pair of factor 1 and -6 and -1 and 6 are the same. However, the sum of the two factors are different. So when you multiply, it will give you a -6, but when you add them, the sum of those two factors is different. One is a -5, one is a +5, and we are looking at a +5. So the difference now with the previous example that I have here, when b is less than 0 and c is greater than 0, both must be negative. In this instance, when c is less than 0, one of the factor is a negative. Okay, because C is negative, the factors will have opposite sign. One is positive, one is negative. So you have to check. So in the factor part, they might give you the same answer as -6, but on the sum of the factor part, will give you different answer. So the factored form of x squared plus 5x minus 6 is equivalent now to x minus 1 times x plus 6. This is the factored form. I'll just stop. There you go. Okay. So our next example is we're going to factor a trinomial with two variables. But no worries. What is the factor of x squared plus 10xy plus 24y squared? So we have to identify the factor of 24. Okay, and then we have to get the factor of 24, and then so I'll just put there factor of 24 and then sum of factors. Okay, so what are the two numbers? 3 and 8. So we are looking at the sum must be 10, and then the factor is 24. 2 times 8, or 3, sorry. 3 times 8 would give us, 24. 2 times 12. Well, right, so 3 times 8. So 3 and 8, 8, that is 11. No. How about 4 and 6? 4 and 6, 4 and 6 will give us 6 plus 4, that's 10. 4 and 6. So the factor form of this one will be using 4 and 6 as the factor of 24. When we add them, it will give you the middle term, which is 10. So just a tip, guys. When factoring a trinomial with two variables, make sure the factors contain both variables. Check your answer to determine whether whether you factored it correctly. All right. So the factored form of x squared plus 10xy plus 24y squared would give us x plus 4y, it's the 4 here, times x plus 6y. So that's the factored form. So if you add 6 plus 4 will give you 10xy, and then you multiply 6 times 4 will give you 24, and then the y squared on the variable part. Okay, now let's apply your factoring trinomial in a word problem. Okay, that's part of our objective. Benjamin is designing a new house. The bedroom closet have one wall that contains a closet system using 3 different sizes, size of storage unit. The number and amount of wall space needed for each of the 3 types of storage unit is shown in the picture. What are the dimensions of the largest amount of wall space that will be needed? First is we have to formulate. The largest possible closet storage system will use all the units. We have to write an expression that represent the wall area of the closet in terms of the storage unit. So I'm going to write that as x squared plus 12x plus 35. Okay, and then we have to factor two number, okay, factor of 35, and the sum would be 12. Okay, sum of 12. 1 and 35, that will give you 36. No. 5 and 7, 5 and 7. So that will give us a sum of 12. So we'll be using 5 and 7 as the factor. So the factor here of that would give us, the factor is x plus 5 times x plus 7. Okay, but I don't understand. So what's the meaning? So we're going to interpret this one. Okay, so we're going to interpret this. What's the meaning of this one? So the interpretation is that the dimension of the largest amount of wall space in this situation will be needed are x plus 7 feet by x plus 5 feet. Okay, so those are the dimension. Okay, I'll repeat. The dimension needed on this would be x plus 7 feet by x plus 5 feet. All right, so that is how factoring is used in the real world problem. All right, let's proceed with the concept summary of factoring x squared plus bx plus c. To factor a trinomial of the form x squared plus bx plus c, find the factor pair of c that has sum of b. So it's the last term of the trinomial. That's the factor of the last term of the trinomial. And then the sum would be the middle term of the trinomial. Then use the factors you found to write the binomials that have a product equal to the trinomial. If b and c are positive, and then we also have b is negative and c is positive, and then we have c is negative. So you have written in there. So you just pause this video and you see, take a look at the concept summary. If you have any problem, if you need more example, join us in our live Zoom meeting. And if you need more support, we have small group support for math. We have 9:15 to 9:45 in the morning. So I want you to see. I want to see you there. Let's support each other to understand the topic that we have here. There you go, guys, and we'll see you in the next video, and hope to see you in our live Zoom meeting. Thank you, guys, and bye-bye.